Sometimes you get 0 divided by 0 if you try to evaluate a limit. For example, if you have sine x over x. What can we do? We cannot divide by 0. In that case, we can often compute the limit using L'Hopital's rule. In this video, you will learn how and when this rule works and why not, and how you can use it to compute these indeterminate limits. So, what is L'Hopital's rule? Suppose you have 0 over 0. So, if you send x to c for f and for c and for g, you get 0. Then the limit of f over g equals the limit of f prime over g prime. So instead of computing the limit f over g, you can compute f prime, you can compute g prime, take the quotient and then take the limit, if this works. Similarly, you can also do this if you don't have 0 divided by 0, but if you have infinity divided by infinity. So suppose both limits for f and g are both infinity, then you can also use L'Hopital's rule. Then the limit of x to c for f over g equals infinity over infinity equals then the limit of f prime over g prime. So let's do a few examples. So first example, our famous sine x over x. Well, sine of 0 equals 0, and if you put x equals 0 in x, you get also 0. So here we have 0 over 0. So we can compute f prime, so derivative of sine x equals cosine x, over g prime, derivative of x equals 1, and then send x to 0. But now we can do so because the cosine of 0 equals 1, so we can 1 over 1 equals 1. We can also use this for slightly trickier examples. For example, x times the ln of x. Now we basically have 0 times infinity, so we don't want that. But from x we can convert that in 1 over x. So we get this over here. Now 1 over x goes to infinity if x goes to 0. So now we have infinity over infinity. So now we can use L'Hopital's rule. The derivative of the ln of x equals 1 over x. The derivative of 1 over x equals minus 1 over x squared. We can simplify now first. 1 over x over minus 1 over x squared equals minus x. And now we can take the limit and we get 0. Third example. We take x to pi over 2 of sine x over cosine x. Well, let's just do L'Hopital's rule. We get cosine x over minus sine x. Now we can plug in x equals pi over 2. Cosine pi over 2 equals 0 and the sine of pi over 2 equals 1, so we get 0. But wait, something went wrong. Something is wrong over here. And what went wrong? Well, we have here sine x over cosine x. If you plug in pi over 2, you get 0 divided by 1, which is just 0. You have not 0 over 0 nor infinity over infinity, so you cannot use L'Hopital's rule. You can only use L'Hopital's rule if you have either 0 over 0 or infinity over infinity. So what we did here was wrong. Now, let's take a short look at the proof. So when can we use L'Hopital's rules? Well, the functions f of g need to be differentiable on an interval not containing c. G prime has to be not equal to 0 because you're going to divide by g prime, so you don't want it to be 0. And you want, of course, that this next limit exists. So if you have done it, you have f prime over g prime, send x to c, then you want the limit to exist. Then you can use L'Hopital's rule. A proof with slightly, quite a bit stronger conditions. If f and g are both continuously differentiable at c, then we have a very nice and short proof. So let's see how it works. Then the limit x to c of f over g. You can add f of c and g of c, because we assume that they are both 0. So we add an f of c and a g at c. Then we add an x minus c and another x minus c. So we're basically adding 1. X minus c here and there. And then we know, well, if both limits exist, then the limit of a quotient is the quotient of the limits. So we can put the limits over here. And now we see we have the definition of f prime of c divided by g prime of c. And we assumed that those limit exists. So there you see that if you take x to c, that the limit of f over g equals the limit of f prime over g prime if you have cases of 0 over 0 or infinity over infinity.